In this topic, we'll turn HIPAA safeguard expectations into practical technical controls for AI systems that handle PHI. We'll connect encryption, access, logging, retention, and disposal to cloud platforms, APIs, models, and data pipelines, so compliance becomes operational, measurable, and auditable. At this point, the groundwork is in place. We've inventoried AI systems, traced data flows, and classified AI risks. With HIPAA applicability and PHI locations now clearer, we can translate safeguard requirements into concrete controls for AI platforms. HIPAA gives us safeguard categories. I requires us to turn those categories into specific control points. Start by tracing PHI through the full system: data pipelines, model inputs and outputs, APIs, vector stores, cloud services, and logs. Then determine what each point needs, such as encryption, access limits, monitoring, retention, deletion, and audit evidence. The goal is not just to have policies. It is to prove that reasonable safeguards operate where PHI actually moves. A mapping matrix is where that translation becomes practical. Each requirement should connect to the AI workflow it affects, the control objective, the configuration or process in place, the accountable owner, and the evidence an auditor can verify. Be specific about PHI locations, including prompts, embeddings, logs, outputs, backups, and training data. Label controls as preventive, detective, or corrective, and maintain review cadence and version history so changes remain traceable over time. For data at rest, protection has to follow PHI wherever it persists in the AI workflow. That includes expected locations, such as databases, object storage, file systems, warehouses, and backups. It also includes AI-specific stores, vector databases, embeddings, cached prompts, model outputs, training sets, fine-tuning data, and model artifacts. If data is derived from PHI, protect it as PHI. Then verify those protections through cloud settings, database parameters, storage policies, and audit evidence. Data in transit needs the same discipline across every hop. PHI may move from a clinician's app through APIs into model endpoints, pipelines, cloud services, and integrations. TLS should be mandatory for user traffic, inference calls, prompts, responses, webhooks, batch jobs, and admin consoles. For service-to-service paths, strengthen protection with certificates, private networking, VPNs, or mutual TLS. Continue monitoring for expired certificates, weak cipher suites, insecure protocols, and exposed endpoints that handle PHI. Encryption is only as strong as the keys behind it. For AI and cloud workloads, use managed KMS or HSMs and separate key administration from application development. Govern the full lifecycle: generation, storage, rotation, backup, recovery, revocation, and destruction. HIPAA evidence should show that the process is operating, not just documented. Collect key policies, admin access reviews, access logs, rotation records, configuration exports, and proof that public or unauthorized key access is disabled. Access logging must follow PHI wherever it moves, not just where it is stored. In AI workflows, that includes prompts, model responses, document retrieval, vector database searches, API calls, exports, and admin actions. Each event should capture who acted, their role, when it happened, the source device or IP, what object was touched, and whether access succeeded. Just as important, avoid copying PHI into logs. Use metadata, references, and identifiers whenever possible. Strong audit trails depend on signals from every system that can touch PHI. Applications, cloud services, identity providers, databases, AI platforms, and security tools. Those records should be centralized, protected from tampering, retained, and checked for integrity. From there, monitoring can detect meaningful patterns, such as bulk exports, late-night access, failed login spikes, unusual prompt volume, or privilege escalation. The operating model matters too. Defined reviews, alert thresholds, escalation paths, and evidence retention. Role-based access control turns least privilege into daily practice. Rather than giving everyone broad access, assign permissions by job function and real need. Clinical users may view patient data, while engineers manage infrastructure without seeing unnecessary PHI. Data scientists, administrators, security teams, and auditors each need different boundaries around datasets, prompts, outputs, logs, and configuration changes. Keep those rules consistent across identity groups, application permissions, cloud IAM, and database privileges. Separation of duties prevents one person from building, deploying, securing, and approving a sensitive AI change alone. This matters when privileged access could expose PHI, change model behavior, alter IAM policies, or disable logs. Treat admin actions as controlled events. Request access, obtain approval, elevate only temporarily, record the session, then revoke and review. Preserve the evidence as well, including tickets, approvals, change records, and access logs. The goal is accountability without blocking legitimate operations. Non-human identities deserve the same scrutiny as user accounts, and sometimes more. A service account or API key can move PHI at machine speed, so avoid shared or generic identities. Tie each one to a specific workload and owner. Grant only the access its function requires, and store secrets in a managed vault, not in code or configuration files. Rotate credentials, monitor use, review permissions, and disable anything unused before it becomes an invisible backdoor. Break glass access should support patient care in true emergencies, not become a shortcut around normal controls. Define who may use it, which situations qualify, how long access lasts, and what justification is required. Every activation should automatically capture the user, reason, systems touched, PHI viewed, and timestamp. Afterward, compliance, privacy, security, or clinical leaders should review the event. Separately, periodic access reviews help remove stale accounts, excessive permissions, and role mismatches before they become risks. AI systems create more than final answers. Prompts, responses, logs, embeddings, training sets, backups, and audit records can all carry PHI risk. A HIPAA mapping should assign each artifact a retention trigger, retention period, disposal method, and proof of destruction. Disposal may involve secure deletion, cryptographic erasure, lifecycle expiration, or verified destruction. Even de-identified data needs documented methodology, residual re-identification risk, and usage limits, because anonymous does not always mean risk-free. The key lesson is that HIPAA compliance becomes real when safeguards are mapped to AI assets, workflows, owners, and evidence. PHI must be protected across prompts, outputs, embeddings, logs, APIs, and endpoints. With encryption, logging, access control, retention, and disposal in place, we're ready to examine risk scenarios and incident response.